So this is a presentation that we gave at Ozri 2015. Just thought I'd record the video, back storeroom, for those that weren't able to make it. I did want to start off with just a quick disclaimer that I'd like to call myself a GIS analyst. I've not really worked with any public transport data in the real world on GIS projects. My background has really been in hydrology. And I'm a big fan of rivers. From a pure networking perspective, they're fairly straightforward. So for the most part, all rivers will flow, nearly all of them will flow downhill. So if you use the ArcGIS online tracing tools, for Australia this is using Ozri data, and as you trace downstream you'll either end up at a sink or more than likely you're going to end up at the ocean. Now if we take it up a step and look at the more typical road network, from a networking perspective, on the surface it's fairly straightforward for the end user. They plug in a start and an end destination, and the routing service will go off and calculate perhaps the shortest route or the quickest route between those two. And you can input additional parameters such as barriers, or I'm driving a truck, sorry, take me down road that the truck's allowed to drive down, or take me from A to B via C, and again the routing service will comply and return you the relevant route. And behind the scenes, building these road network data sets actually requires a lot of complex rules. So there's different speed limits to take into account, the width of the road, there's different turn rules, and of course traffic. So either taking into account the real-time traffic, or if you want to leave tomorrow at rush hour, looking at historical traffic trends to work out how long that's going to take tomorrow. So how easy is it to actually build a network data set that allows for networking with public transport? Now for Victoria there's many public transport carriers, but fortunately all of these different carriers for trains, buses and trams, they're all done on by independent carriers, but they're managed on contracts from one agency, the Public Transport Victoria, otherwise known as PTV. So PTV have dished out a number of shapefiles on data.vic, the train lines bringing commuters into the city and back out again. There's the tram lines connecting the metro suburbs together. And then you also have the bus routes, particularly important in the outer suburbs and rural areas, and also they're quite useful getting from east to west in the city as well. Now along with these shapefiles, PTV also dish out two key data sets that myself and a lot of people in the developer community have been taking a keen interest in having a play with. Now the one on the right is the timetable API. This is a web service. So you can actually ask this web service for real-time transit information. So you could develop an app that tells you, from my current location, where is the nearest transit stop and what are the next buses, trains or trams that are going to be leaving from that stop. Or are there any disruptions on the network right now, and tell me where they are. And you can actually hook into that API through the GeoEvent extension to bring that data into ArcGIS. But today I'm going to be looking at the static timetable data. Now this is in the GTFS format, I'll talk about that in a sec. Specifically what I want to do is incorporate this timetable data. And this is the same timetable data you actually see at the bus stop on that timetable that you see there, and in the journey planner that PTV dish out. This static data, I want to bring this into ArcGIS into a network data set. Then I'll be able to perform routing and cost distances and all of the other fun stuff that you can do with Network Analyst. So those watching the video that aren't from Victoria, hopefully you're still watching. There's a number of GTFS data sets for other states. I know Darwin, I believe they have some data, but it's not yet open. TransLink, there's data from southeast Queensland right up to Toowoomba and Bundy. I was going to take a look at the metro data for Launceston and Hobart. I know Ebony up in our Sydney office is also looking at the Sydney data. And if you're playing around with these data sets in ArcGIS, I'd be really interested to know how you're getting on. Perhaps throw some comments underneath this. So GTFS, General Transit Feed Spec. This was originally developed by Google, and really it's for transit departments across the world to supply their timetable data in a standardized format, and it's also so that you can get it into the Google platform, so you can consume it from your Google Maps app, so that you can do routing using the Google Maps application. But we can still leverage this standardized format within ArcGIS. The zip file that you download has 11 subfolders. Sorry to lie, it's 10, missing out 9, not quite sure why that is. And within every one of those folders, there is the GTFS data, 8 CSV files that describe the timetable for each transport mode. And you can do a little bit of stuff with this data. There's lat longs in there and add event XY data to ArcGIS. But you're better off going to ArcGIS Online and downloading a free set of transit tools that will help you work with this GTFS data. They include step-by-step documentation, which was really pretty easy to use. So I'm just going to walk through the process of using probably one of the most popular toolboxes in those tools, getting the GTFS data and bringing it into a network data set. And the first step is to actually generate some spatial layers for the stops and the transit lines. So if we open up ArcGIS for desktop, we can open up this first step of the scripts and point it to either one or multiple GTFS directories. So perhaps you're just interested in one or two of those transport modes. I'm looking at just the metro ones for trains, trams, V-Line and the buses. And you can then point it at an empty feature data set that you've created beforehand. So this is one I created in the VicGrid coordinate system. And then it goes off and starts crunching through that data. So it creates a SQL database. Now this contains the processed GTFS data, and it's housed in the geodatabase itself, and this is used later on for the network analysis. It also creates a points layer for your stops, so every stop location where passengers can board or disembark the trains, trams or buses, and then a line layer for your transit lines. Now a line is created between each pair of stops that is directly connected by a transit trip. So it's just going through the 4 directories. It can take a bit of time. This is all of the data for all of Victoria, all of those buses. The buses are the big one there. I think that's directory 4. So these are all of the stops, fairly self-explanatory. And then here are the transit lines. Now you might be suspicious of some of those lines that obviously don't follow the roads or the train lines, and that's because these are express links. They skip out a lot of the stations, and those lines are just between stops where there's a direct trip, so that's okay. It works fine in the analysis later on with service areas and cost distances and so forth. So for me personally, getting from home to work involves getting the number 86 tram from Thornbury up in the northern suburbs, which takes me down to the CBD along the tram lines. But I still have to walk from my doorstep to the tram stop, and at the other end I have to get off at Collins Street in the CBD and then walk up about 500 metres or so up to Franklin Street. And that's on the road network, like along the pavements. So we've got 2 different data sets there. And then if you think about it more, some people might drive their car to work, they drive their car to the station, park it, hop on a train, and then get off at the other end and walk to work. And with some commuters, their trips can get quite complex. They walk to work, walk to the station, jump on the train, jump on another tram, and then walk to work. And it can get quite complex. A lot of people bike to stations and park their bikes at the station. And all of these workflows can be done, but to avoid overcomplicating things, I'm just going to assume walking to and from stops with the option to either jump on a train, tram or a bus that we just saw processed then from the GTFS data, but you can factor in those multiple travel modes. Because we're using several modes of transportation, from walking on the pavements to driving on streets to taking the trams, trains and buses, we need to combine these into what's called a multimodal network dataset. Now, the second step in the process, the stops that we produced earlier from the GTFS data, they're unlikely to fall directly on top of the street network. And being GIS, we need to ensure that there's connectivity between those stops and the street network. So let's just say this is a train line and this is a station. This is the train station stop here. We're without more detailed data around the platforms and the pathways around the station, we can just make the assumption that once you get off the train at this station, you need to be able to walk directly to the nearest street to continue on your journey on foot. And that's what this script does. It first of all creates a copy of the stops layer and snaps it to the nearest street within a given tolerance, and then creates a line between those two, and then it duplicates the entire street network with an additional vertex at that point, which can take a bit of time processing wise. Then you have to create your network dataset. So give it a name. Then you include the feature classes that were created in the prior steps, so the stops and transit lines created from the previous tool, along with the stops that have been snapped to the streets that have been included with additional vertices that have been formed from those connectors between the stops and the streets. Hope that makes sense. If it doesn't, the documentation goes into a lot of detail around all of these. And then you have to set up the connectivity rules. So this was actually new to me, but it's very important. It ensures that, for example, the pedestrians can only change between the transit network and the street network, and only the pedestrians. It separates out the streets network from the transit network. So if a train suddenly gets to a junction where there's a street crossing it, the train can't suddenly drive down the road. And likewise, cars, they can't suddenly jump onto the train network and drive down the train line. But the pedestrian, they can jump between the two. Next is creating a special evaluator that will read and interpret the GTFS data. So starting from the top, these connectors, stops to streets, these are those lines between the stops and the streets. Now this is optional, but you can set a value here. 0.25 simulates a time penalty of 15 seconds for boarding and disembarking a train or tram. You could put that to 0 if you preferred. Next one is the streets. So I'm going to take the assumption that if you're not on board public transport, you're basically on your feet, you're walking. So calculating the travel time along a street, my distance unit is in meters, so that 80.46 there, that's 80.46 meters a minute, which is 5 kilometers per hour in my units of meters per minute. So this is the average walking speed, taken from Wikipedia. Now for the transit lines, you need to use a special transit evaluator, which is supplied in the download of the tools. It's just a DLL you register. And this evaluator will query the GTFS timetable data to figure out how long it's going to take to travel on the transit lines. And because transit trips really only go in one direction, each of those lines was for one direction for each way, the to from can be set to -1, ignore it. The final step is just to run this get network EIDs. This needs to be done after you've built your network dataset. You point it at your network dataset, then updates that SQL database that contains the GTFS data with the corresponding network elements from the network dataset. Okay, so I've already cooked up that bus, train and tram GTFS data with a street network dataset that was provided from here, but there's nothing stopping you from perhaps mashing this up with OpenStreetMap data or a street layer of your own. So here we are on desktop, and here is my layer, the network dataset layer. If I go to Network Analyst and do New Service Area, this whole task has been a selfish kind of, for me, trying to work out where to live. And this is my office location here, Ozri, Australia, in the CBD. I would like to create a detailed polygon. I want to ignore the transit lines. That's just because I don't want to have service areas going up alongside the train line and alongside the tram lines, because you can only get off at a station. And for me personally, I'm only willing to commute 45 minutes. I need to be at my work at 9 AM in theory on a typical weekday, so we'll say Monday, and we're going towards my office. And we've got the walking restriction here, which is important, otherwise it's going to start letting me walk down highways and other areas where I shouldn't be walking. Okay, so just add a point to somewhere near enough my office. I'll do for this. This process here, this just happens once per ArcMap session. It's just caching that SQL database. I believe it's just caching it into the ArcMap memory. So every subsequent analysis I do, be it service area or routing or cost distance, we'll use, it doesn't have to do that every time. It's just a one-off process. So this might take a little bit of time. So yeah, as you know, real estate prices in Melbourne are, at the moment, at the time of this video anyway, they're pretty high. So I really wanted to see if I could find some areas that I might not have perhaps thought of that were still within 45 minutes commute. Like you kind of think you know where those areas are just because of, I mean, you can do a drive time from the city, but realistically I'm never going to drive to work. I'm always going to take public transport. So yeah, I wanted to see if there was any kind of particular pockets further afield that might have express links in, for instance. So once it's done this, it's also then going to have to generate, because it shows a detailed polygon, it will have to create the detailed polygon, which also might take a little bit of time. You can also install this DLL. I mean, you can publish it to ArcGIS Server and serve it up to ArcGIS Server, but I haven't done a lot of experimenting with that yet. But we do have a partner called MobiGIS that have some server object extensions that really allow for, from what I've seen of their tools, they seem to be a lot quicker than the analysis that I'm doing at the desktop level. I'll hopefully be doing a blog post on that in the near future. So it's just crunching that service area. Again, I could have chosen generalized, but again, for me, I really want to see right down to the street level, where can I actually walk. Like people always say it takes them 45 minutes to get to work, and it's like, no, it doesn't. It takes you 10 minutes to get to the station, you've got to wait another 10 minutes for the train, then it takes you 40 minutes to get to the city or wherever. So this really does take into account right from your doorstep, right the way to your work doorstep. Okay, come on, running out of things to say. Okay, so that is my service area. We'll just change that to a big bright red. And my partner, so I'm just going to create another service area, and she works over here, and we're just going to have, just to really emphasize that you can change these settings. She's actually happy spending 60 minutes for a commute. Lucky for her, she has to get there at 7 AM, and we'll stick to the weekdays. She's going towards the facility, and we'll make those detailed polygons as well. Get that crunching. Just need to shift. So I should have enabled snapping, my bad. Okay, so that's now crunching. So you can see this time around it didn't have to cache that GTFS data into the ArcMap memory. It's just going straight into generating that service area. What I'm trying to do here is, I won't do any further analysis from here, but the resulting polygon that it generates, the overlap between these two service areas, it means for me and my partner, we can then just target those areas that overlap, forgetting about the fact that there's a number of other considerations you'd want to take into account for real estate. I might put that into another blog post, but things like crime data and, well, the important one really, like the house prices, that's what you want to overlay next really. So just make that big bright blue, and just zoom to the extent of this, and we're going to delay it. And this, well, it's quite clear, you can see the overlap in the two. You suddenly start to find, I mean, I was actually genuinely surprised, there was a number of areas that were actually quite far away, that we could both live and still be within the constraints that we just fed in. It's worth pointing out that the data is very time aware, so especially for areas out here, in fact we'll see this in a sec. So here's a story map I put together, just kind of illustrating some of the analysis I did with the tools. This is getting to Flinders Steps in the CBD for 8:30 in the morning on a Monday, 30 minutes, 1 hour, 1.5 hours, and 2 hours. And that's all good and well, if you need to be there exactly 8:30. But In terms of the data being really time aware, this is a series of services that have been. I'm going to start that again. So this is just walking times. It's just walking to work because there isn't any public transport at 5 in the morning. But as the day goes on, we're just looping through in 5-minute intervals here. We can see how drastically those service areas change over time. So once you get to around 6 o'clock, it kind of stays fairly simple. But you can see these outer, these regional areas out here. Well, they're not regional, but the outer kind of metro areas, they change quite. They kind of shrink and get smaller as those express links run a lot less frequently than trips that are in the city. I thought that was quite cool. What's this one? So this is, I guess, just a more finer grained service area. So instead of just one block, we've got a series of different. I've got the best internet reception out here in the storeroom. So yeah, just finer grain, so we can actually jump in. I'm particularly looking around Footscray, which is this area here, so I can actually do a bit of geo-enrichment and find out exactly for the short list of properties I have, what are the travel times using public transport. But again, it's not just about, you need to take into account the frequency of those trips. So there's additional tools that I haven't got time to go into here that are available in the ArcGIS Online Transit group that allow you to do things like calculate the number of trips per hour from that GTFS data. If we switch that to a quantile classification to avoid the skew being just around the CBD, which obviously there's lots and lots of trips, you can see, all right, well, which of these outer pockets of suburbs is there still quite frequent areas of a frequent number of trips per hour. And then I guess the opposite of that is the wait time. So you don't want to be waiting around for ages. This is only up to 60 minutes wait. Obviously there's a lot, everywhere in the grey area is more than 60 minutes. And again, I would advise you, if you want to know more about these tools, they're quite complex. It actually creates a very small, well, it's up to you what you decide, but creates a service area around each stop before calculating, well, within that service area of that catchment, what is the maximum number of either trips or the wait time within that area. That's not a good explanation, but have a look at that particular tool and the docker behind it. So apart from my real estate, this is fictional and it might just spark some ideas for anyone watching this or still watching it. You could do other things like generate small service areas around your. So I had a flatmate that used to, whenever we had a few drinks, would always just want to disappear and go find a McDonald's to go get some food. So this is what is it? I can't remember what I did. It's a 10-minute walk around each of the McDonald's, and then saying, well, look, within each of these 10-minute walks around each of the Maccas, what are the number of trips per hour that are available for public transport, specifically between 9 p.m. and 12 a.m. So you can set up time windows when you're using these tools. This might help you decide when you want to close your Macca's branches, perhaps. Night Rider, I've never actually been on this, but I was quite impressed that it exists. I believe PTV might be even offering 24-hour public transport in the future. The Night Rider is a bus that just allows you to get from the CBD to other places when most of the other public transport closes down. And yeah, this page here is, you can get to them from ArcGIS Online, but Melinda, she's the one behind these tools from the Ozri network analyst team. And yeah, this is a site which kind of goes into a bit more detail about the tools. Hopefully you found it useful. Like I said, if any of you have been inspired by this to start using these tools to work with your own state's data, I'd really be interested to know. Just fire some comments in the below if you have any problems, or maybe put together a story map of your own and share it here. Thanks.